Hello and welcome to Potential to Emit. This module is brought to you by the Environmental Compliance Assistance Program, which is part of the Energy and Environment Cabinet. Potential to Emit is crucial in determining the type of air permit your facility might need. We have discussed what PTE and permitting thresholds are in previous modules, so I would encourage you to view those first, as in this module, we will be going through examples on how to calculate PTE. In our first example, we see a facility that is currently working under a registration from the Division of Air Quality, but who wants to expand their operation. This raises some questions, which we will cover in the upcoming slides. First, we must ensure that the facility is properly permitted after the addition of the new process. We must determine if the permitting status has changed, meaning do they need to get a new permit? Have they crossed the permitting thresholds? Or can they continue to operate under the existing registration? To determine the level of permit needed, we must first determine the PTE by evaluating the combined emissions of all emission sources, including the new process. If it is determined that a new permitting threshold has been reached, then the facility will require a new permit. But if the additional process does not raise emissions to a new level, then the facility can simply modify the existing coverage. The facility walkthrough is a great way to identify all potential emission sources. A simple diagram of the facility and process flow can help ensure that all applicable information is gathered, including any control devices that are in place. For our bright and shiny chrome company, the walkthrough has been completed and the diagram has been developed. What might need to be included in their permit? Things like tanks, grinder, sander, welding, and parts cleaning operations are all potential air emission sources. Are there any control devices that should be considered? As you can see, there is a scrubber, filter, and the building itself can act as a control device as an enclosure. It is very important to include all control devices, as these could be the difference in what level of permit your facility is required to get. Based on researching equipment specifications and safety data sheets, we can figure out the control efficiencies and what the control devices capture. This slide lists out the different emission sources for the facility. Here we can see what type of control equipment is being used for each emission source. It is important to remember that every kind of control device is only effective for certain pollutants. Usually, this information can be found in the equipment specifications. Finally, this slide provides the control efficiency. How much of the pollutant is the control capturing? If you cannot find the control effectiveness or efficiency, the EPA has a list of fact sheets for many different types of control devices that cover control effectiveness efficiencies at this link on the slide. This simple technique of breaking down each emission units, associated controls, pollutants captured, and control efficiency is a great way to ensure your PTE is accurate. This slide shows us the PTE for the facility. Both controlled and uncontrolled levels of applicable pollutants are listed. We can see the amount of air pollutant, along with total hazardous air pollutant levels. Notice the PTE is in tons per year. Paying attention to units is crucial for accurate PTE calculations, and you always want to report emissions in the units the Division of Air Quality is asking for. In this case, we can see that the regulated air pollutants are all under 10 tons per year. Hazardous air pollutants are all under 2 tons per year individually and 5 tons per year total. Based on these totals, no registration would be required. It should be noted that the Environmental Compliance Assistance Program recommends submitting for registration to allow the Division of Air Quality to confirm PTE totals and provide verification that nothing is required. The facility must also determine if any federal regulations apply to them, because if they do, a registration at a minimum will be required. If the facility wanted to lower its potential emissions from state origin permit levels to registration levels, How might they go about doing that? This question can have many answers, but essentially, whatever the facility can come up with in order to lower potential emissions. This could include using different products, such as plating liquid, solvents, and more. It should be noted that new controls would not decrease the PTE unless they are integral to the process, meaning the equipment would not function without the control operating. Bright and shiny chrome is expanding again, this time adding 2 gas metal arc welding units, so they can refurbish some steel cylinders prior to plating them. In the following slides, we will go through the steps required to calculate the PTE for the new welding operations. As before, the facility layout is a great place to start. You can see here that the 2 new welding units have been added. From welding, the main source of emissions comes from the melting of the welding rod, or wire being used. We will need to figure out how much they are using per hour and how much they could use in a year in a worst-case scenario. Since there is no set throughput in welding, we will have to calculate actual usage for the PTE calculations. This slide provides us with some crucial information that we can use to determine potential particulate matter, 10 micrometers or less, PM10 emissions associated with the process. This information includes that first, the welding will be conducted 4 hours a day, 5 days a week, and secondly, that the facility will use 500 pounds a year of welding wire. To figure out how much material is used by a process, in this case the welding rod by the new welders, we will take the actual operating time and the estimated usage rate and multiply them together. Step 1 determines the operation hours of the welding. 4 hours a day times 5 days a week times 52 weeks a year gives us 1,040 hours per year. Step 2, wire usage. 500 pounds per year divided by 1,040 hours per year equals 0.48076 pounds per hour. Remember, always follow the units when calculating PTE. Step 3, potential usage. Here we take our actual usage, 0.48076 pounds per hour, and multiply it by the number of hours in a year, which is 8,760. This gives us 4,204.8 pounds per year. Remember, potential emissions assume the process will run non-stop at full capacity. Step 4, convert to tons. We now have our PTE for the welding process in pounds per year, but the Division of Air Quality asks for it in tons. To do this, we will simply take our pounds per year total of 4,204.8 and divide it by 2,000, since there are 2,000 pounds in 1 ton. This gives us a total of 2.10576 tons per year. Next, we will need to determine our PTE for PM10, so we must locate the correct emission factor. Here we have the welding emission factor from AP42, which is a compilation of air emission factors that can be found on the EPA webpage. We are dealing with a GMAW and E7OS wire, which is toward the bottom on the on-screen graphic, which is a representation of what you would find in the AP42. We just blow the relevant line up a bit, and the emission factor is 5.2 pounds per 1,000 pounds. Notice this emission factor is given in pounds per 1,000 pounds, and we need pounds per ton. So how do we make that conversion? Since there are 2 sets of 1,000 pounds in a ton, which is 2,000 pounds, we will just double 5.2, which gives us 10.4 pounds per ton. Now we can continue to calculate our PTE for PM10 associated with the welders. Here we can see the basic formula for determining our PTE. Potential yearly usage times emission factor equals PTE. If you remember, we have just determined that our potential yearly usage is 2.10576 tons per year, and our emission factor for the type of welding and wire we are going to be using is 10.4 pounds per ton. In this example, we can see that the tons will cancel out and give us an answer of 21.9 pounds per year. However, our answer needs to be in units that the Division of Air Quality require, which is tons. Our final conversion to tons per year can be made by taking our total of 21.9 pounds per year and multiplying that by 1 ton over 2,000 pounds, which will cause the pounds to cancel out and give us our total of 0.01095 tons per year. Are there any controls that might lower emissions? The building itself can act as a control on the welding process. Welding generates almost entirely particulates, so an enclosure can be an effective control. The effectiveness of the building as a control can vary between 50 to 70%, depending on the conditions. If you have a large bay door that is generally kept open, or some other large or nearby exit point, then the effectiveness will be assumed to be 50%. If the equipment is away from doors and windows, or there is not another large or nearby exit point, then we can assume a 70% control efficiency. It does not look like there are any doors or anything in that corner of the shop, and the equipment seems to be pretty contained, so let us assume a 70% control. Now, we will take our 0.01095 tons per year and multiply by the amount of emissions not being controlled, so in this case, 30%, or 0.30. This gives us a control PTE of 0.003285. The Division of Air Quality will require both controlled and uncontrolled numbers to be reported, unless the control is integral to the operation of the equipment. After determining the uncontrolled and controlled PTE for each pollutant, and combining the results from all of the processes, we come up with these values for this facility-wide PTE. Did they increase to a new permit threshold? No. So what should they do? They do not need to resubmit. They can do a minor modification, which just involves sending a letter and specifications on the new equipment to the Permit Support Branch of the Division of Air Quality. Let's try another example of a permit application. Here we can see that Chuck Wood Products are looking to expand by building a new facility. As before, the first thing to do is to identify all emission sources and control devices. Remember our facility walkthrough process. We must also determine our emission factors for each process. The facility layout and process flow allows us to see all potential emission sources, as well as control devices. The emission sources are shown with blue arrows. Some examples of an air emission source would include the boilers and paint booths, while control devices would include the baghouse, dust collectors, and the building itself. Let us take a second to run through an example of calculating PTE. Chuck Wood Products has a natural gas boiler that is rated for 8 million British thermal units, or MMBTU, per hour. Natural gas has a heat capacity of 1,020 million British thermal units, MMBTU, per million standard cubic feet, MMSCF. There are no control devices, and we need to determine the carbon monoxide emissions. Step 1. Convert the BTU rating to MMSCF. To do this, we take our 8 MMBTU per hour boiler rated capacity and divide by our natural gas heat capacity of 1,020 MMBTU per MMSCF. The MMBTU will cancel out and give us an answer of 0.00784 MMSCF per hour. Step 2. Convert to hourly emission rates. We can find our emission factors using AP42. Remember, AP42 is a compilation of air emission factors located online. There we will find it as 84 pounds of carbon monoxide emitted per million standard cubic feet of natural gas burned. Multiplying these two gives us 0.65 pounds of carbon monoxide emitted per hour. Step 3. Calculate the potential annual emissions. So we have found our emission factor and determined our hourly emission rate. Now we can easily convert that hourly rate to a yearly total by multiplying by 8,760, which is the number of hours in a year. 0.65882 pounds per hour times 8,760 hours per year will give us a total of 5,771.29411 pounds per year. Again, make sure to watch your units. The hours will cancel out on this one. Step 4. Convert to tons. Remember, follow the units when determining PTE. We must get our final total in tons per year, so we will multiply the 5,771.29411 by 1 over 2,000. This setup allows the pounds to cancel out and our total to be divided by 2,000, which gives us an answer of 2.88564 tons per year. Standard practice is to report values to 2 decimal places, to 2.89 tons per year. Paint booths are a common source of volatile organic compound emissions, and the safety data sheet associated with the products used will be a valuable tool to determine associated emissions. We know our paint gun is rated at a 4.5 gallons of paint sprayed per hour, so let us get started. First, we must find the VOC content of the paint. As stated before, the safety data sheet will be a vital tool for determining VOC content. In this example, the answer was not available in that safety data sheet, but luckily the stain has an environmental data sheet which contains the information we will need. This is a common occurrence, and there may be times where you will have to contact the product manufacturer to obtain applicable information. Step 1. Find the VOC content. We did this using our EDS and learned that the VOC content is equal to 4.38 pounds of VOCs per gallon. Step 2. Hourly emissions. The gun is rated for 4.5 gallons per hour, so we will take that and multiply it by our VOC content of 4.38 pounds per gallon. Our gallons will cancel out and give us a total of 19.71 pounds of VOC permitted per hour. Step 3. Convert to annual. We will take our hourly total of 19.71 pounds and multiply by 8,760 hours per year. The hours cancel out, giving us a total of 172,659.6 pounds of VOCs per year. Finally, Step 4. Convert to tons. 172,659.6 pounds per year times 1 ton over 2,000 pounds allows the pounds to cancel out, and to be divided by 2,000 to give us our answer of 86.3298 tons of VOCs emitted per year. We want to stay consistent in the way we report our values, so we will need to round up our total to 2 decimal places. This gives us a final amount of 86.33 tons per year of VOCs for the stain. Way back in the beginning, we talked about controls, including fabric filters. Fabric filters are common control devices for paint booths and are highly effective for particulates. However, they are not useful for gaseous pollutants like VOCs. They just go right through. Vehicle traffic can result in an emission of particulate matter known as fugitive dust. The important thing here is the length of the haul road and the fact that it is graveled. Using the formula provided, we can calculate the emission factor in pounds per ton of particulate matter. The haul road is 0.40 miles and is unpaved. So using the equation, we now have 2 times 0.40 times 7.80, which is the emission factor for unpaved road greater than 0.25 miles. We take this number and divide it by 30, which gives us a total of 0.208 pounds per ton of total particulates from the haul road. Now we can finish out the emission calculation for the haul road. All of the information listed here will help us calculate the throughput on that road. We now know that the facility will have 1 delivery of wood per day using a truck that can haul 1.5 tons of wood, and that the facility will operate 8 hours a day. Our first 2 steps in calculating the emissions associated with the haul road result in going from tons per day to pounds per hour. It is a straightforward process as long as the units are kept straight. Step 1. Calculate hourly throughput. 1 delivery per day times 1.5 tons per delivery gives us 1.5 tons per day. We can then divide that by 8 hours per day, giving us 0.1875 tons per hour. Step 2. Calculate hourly emissions. We do this by taking our 0.1875 tons per hour multiplied by our emission factor to be 0.208 pounds per ton. The tons cancel out and gives us a total of 0.039 pounds per hour. Step 3. Calculate potential annual emissions. We will now take our 0.039 pounds per hour and multiply it by 8,760 hours per year, which gives us 341.64 pounds per year. In this step, we have gone from pounds per hour to pounds for the entire year. Finally, step 4, we are going to convert to tons. Before we finish by converting to the units required by the Division of Air Quality, we need to get our total from pounds per year to tons per year, and we do this exactly as before. We take our 341.64 pounds per year and multiply by 1 ton over 2,000 pounds. Again, we set it up this way so the pounds will cancel out. This gives us our total of 0.17082, and it gives us the units we need in tons per year. The Environmental Compliance Assistance Program hopes you have enjoyed this module, and we encourage you to reach out to us if any further assistance is needed, not only for your air permits, but for any other environmental issues you may need assistance with. Thank you, have a great day.